For our next example, we're going to continue our introduction to object-oriented programming. And in particular, we're going to revisit the GradeBook class, and for the first time, we're actually going to store grades inside a GradeBook object. So let's go ahead and load up the program here. And the first thing I'm going to do is look at the test class, the GradeBook test class, to show you how we create the GradeBook object and what we tell it to do. Then we'll go ahead and take a look at the GradeBook class. I'll also show you the output here as we look at main. In fact, let's just go ahead and run the program. And you can see that we're producing a slightly larger output than what we've done in prior versions of the GradeBook. We're going to display the welcome message, a summary of all the grades, so we have 10 students and their various grades on an exam. We'll show you the class average, the lowest and highest grades, and then also a grade distribution bar chart with asterisks representing the number of grades in each given range. So let's go back over to main, and you can see in main that we've hard-coded an integer array called grades array with 10 grades already in it. And now what we're going to do is modify the GradeBook constructor, and it's going to receive not only the course name, but the array containing those grades, and it will use both of those to initialize a GradeBook object. So we'll store the contents of grades array in the GradeBook, then we'll tell the GradeBook to display its message and to process the grades. And as you'll see, process grades is going to produce that nice output that we just showed you. So let's go over to the GradeBook class. And when you're designing any class, one of the things you have to consider is the state information, the data that is necessary for representing an object of that class. And even back when we first introduced the GradeBook, we talked about the fact that a typical paper GradeBook not only is going to have the course name, maybe a course number, but it's certainly also going to have information about the students and their grades. And this is just an enhancement of the GradeBook to get to the point of actually storing some grades in the GradeBook object. And of course, a real GradeBook object would probably be even much more elaborate than this version or the other version we'll take a look at after discussing multidimensional arrays. So our GradeBook class has as its data a private integer array called grades. The default value of this variable grades will be null until I go ahead and assign it an actual array object. We also have an auto-implemented property for the course name that has a default get and set accessor to allow us to set the course name to a specific string and to get its value as well. And now we see our modified GradeBook constructor, which now requires two arguments, the name of the course as a string and an integer array representing the grades. And we're simply going to take the reference grades array and assign it to the grades instance variable. So now both grades and grades array point to that same array object in memory. Our display message method has not changed, so we'll just skip right by that. And now remember in the GradeBook test class that we called process grades after calling display message. So let's take a look at the process grades method. As you can see, it's calling other methods in our class. We have one called output grades, which shows you the summary of all the grades for the students in the class. Then we're going to display the average of all those grades by calling our own getAverage method. Again, when you see a method name by itself followed by a set of parentheses, that's an indication that you're calling one of your class's own methods. So we're doing that for output grades, getAverage, also for getting the minimum and the maximum of all the grades, and once again for output bar chart. So we've got several different methods that we're calling from process grades to produce the output. Now let's jump and take a look at output grades first. So I'm going to go to the definition, and you can see that we display the string the grades are, and then we're using, in this case, a counter-controlled loop to iterate through all of the grades. And the reason we did that is we wanted to have access to the index number for each of the students so that we could produce this first part of the output that lists student numbers. Now, as you know, arrays are indexed from 0, but what we did is add 1 to the index each time to show the student numbers as students 1 through 10. So we have a student counter that counts starting from 0 as long as it's less than the number of grades in the array, the instance variable grades. And for each student, we're going to display in a field of 2, right justified by default, the value of student plus 1, the counter value plus 1. And then we're going to display in a field of 3, right justified, the grade for that particular student. And notice we also have a colon and a space separating our two placeholders in the format string. So that's what's producing the output that you see here with the nice right justified set of student numbers and then the right justified set of grades. Now going back up to process grades, the next thing we did was to call our getAverage method and display the result of it in the placeholder 0:f inside of curly braces. Remember that the F indicates that we're outputting a floating point number, and the default is to do so with 2 digits to the right of the decimal point. If you wanted to do some other number of digits, you could put that number of digits to the right of the F character. So for example, if you wanted 3 digits, you could say F3 to get that. Now let's go take a look at getAverage. And as you can see for getAverage, we start by declaring a local variable total, setting it to 0. We then sum up all the grades, and this time we did use a for each repetition statement because we didn't need the index numbers. We just need every grade value to be added to the total. And then we did a return of a average calculation where we first cast the int called total to a double, then we divided that by grades.length, which is the total number of grades in the array. And because it's a double divided by an integer, we wind up with a double divided by a double through C#'s promotion rules, and that gives us a double result. Another way to do this so that we didn't need the double cast operator would be to simply declare the total as a double and then add the grades to the double variable total, in which case total would be a double and we would divide it by an integer and we would still get a floating point result. So that gives us back our average. The next thing we did from process grades was to call getMinimum and getMaximum, and both of these methods are pretty similar. Let's get them up on the screen here. So here's our getMinimum method. We start by assuming that the grade in element 0 of the grades array is the lowest grade, and then we walk our way through every element of the array, comparing the current grade in a given iteration of the loop to low grade. And if the current grade is less than what's already stored in low grade, we then modify low grade to be that value. And by the time we finish that loop, low grade will contain the lowest of all the grades in the array. And we do the same thing for getMaximum. We make an assumption to start out. We assume that the grade in element 0 is the highest grade in the array. Then we walk our way through all of the grades and compare each one to the highest grade to see if it's greater than the highest grade. For any one that's greater, we will modify high grade to be that value, and then by the time we get out of the loop, high grade contains the largest value. And then the last thing we did in our process grades method was output our bar chart, and that's using techniques that we already looked at earlier in this lesson. So if I scroll down here to output bar chart, we've already seen this basic setup and this code in an earlier example. Once again, we're displaying a grade distribution. We create a frequency array with 11 elements representing ranges for grades from 0 to 9, 10 to 19, 20 to 29, et cetera, 90 to 99, and then grades of 100 would be stored in element number 10 within that array. And we are assuming in this example that all the grades are valid numbers from 0 through 100, so we're not doing any error checking on those values. We then summarize the results by incrementing the appropriate frequency counter for each grade. We divide the grade by 10, which is an integer division. Grade is an int, and 10 is an int32, which is an int in .NET framework terminology. So when I get an integer divided by an integer, the result is an integer. So if the grade was anything from 0 through 9, dividing anything from 0 through 9 by 10 results in 0. If it's 10 to 19, dividing any of those numbers by 10 gives us a 1. 90 to 99, dividing any of those by 10 would give us 9, and dividing 100 by 10 would give us 10. So you can see that we would increment one of the counters in the range 0 through 10 based on the value of the grade divided by 10 in the index of the frequency array. And then we simply use the same for loop that we did in an earlier example to display all of the grade values preceded by labels, and then, the grade ranges rather, and then the bars representing each frequency. So that produced this part of the output at the bottom of the program. In a subsequent example, after we introduce multidimensional arrays, we'll take a look at rows and columns of grades, where each row represents one student's set of grades on multiple exams, and the columns are the grades for a particular exam.